This is my lab report for lab number 1 in Physics 2. The goal of this lab was to determine approximately how much excess charge is on a piece of charge-clear tape. This lab covered concepts in Physics 2 such as electric charge, electric force known as Coulomb's law, charge conservation, force equilibrium, and modeling of physical systems. My main results were that I found that the excess charge on the U tape to be positive, and that approximate charge value to be 2.33 times 10 to the negative 8th coulombs, and the tape was found to be deficient of approximately 1.46 times 10 to the 11th electrons. A quick and simple outline of this lab was first we made and tested charge tape, then we determined the sign of the charge, and then lastly we measured that charge magnitude. Some important key Physics 2 concepts to note in this lab are first the point charge model. As seen in the second picture, tapes would normally interact at multiple angles, and it would make for very difficult calculations. So in this lab, we assumed a point charge model in which each tape was just assumed to be a point charge to make those calculations simpler. We also assumed that both tapes were of equal charge, and we used Coulomb's law, the electric force formula, to calculate the charge of one tape and, in essence, the charge of the other tape as well. We also assumed force equilibrium, and we assumed that the net force to be equal to 0. So in this case, tape B was our system, and we assumed that the force that was acting on tape B from tape A was equal and opposite to the force acting on tape B due to the Earth, or the gravitational force. Also, the gravitational force is simply the mass of the object that Earth is acting on times the acceleration due to gravity near Earth's surface, which is 9.8 meters per second squared. We also needed to use charge quantization to find the number of electrons that were deficient on the tape. As previously stated, the system was tape B, the surroundings were tape A and Earth. In our initial conditions, we measured the tape mass, the tape length, the tape width, the tape area. We were given an atom length, and we determined atom area. We then determined the number of atoms on a piece of tape by taking that tape area and dividing by the atom area. Key assumptions we had to make in this lab: we had to first assume that each U-tape has the same net charge. Then we had to treat each tape as if all of its charge were located at a single point at the center of the tape. In other words, we assumed a point charge model. And then we also assumed static equilibrium, and we neglected external forces that are not tape A or the Earth. Some quick details of the experiment. So we took tape A, which is the tape that's lying below, and we hovered it underneath tape B and slowly brought it up until it measured the distance at which tape B began to float. Measured the distance between tape A and tape B, and this was found to be about 0.05 meters. So quick details of the experiment in terms of calculations. We first equilibrated the gravitational force and the electric force and then by equilibrium them, we were able to solve for the charge variable in the electric force calculation. And that charge was found to be 2.33 times 10 to the negative 8th coulombs. Then we used the quantization formula in order to solve for the number of electrons, which was 1.46 times 10 to the 11th. And then since that charge was positive that we found, we know that there's a deficiency of electrons on the surface of tape B. And then we used that number of atoms we found earlier, divided that by the number of electrons we found, and we found that the ratio was about 3.0 times 10 to the 6 atoms per deficient electron. In terms of the coding in this experiment, what I simply did was I plugged in my constant values. I also plugged in my initial values I found in the experiment, and I created two objects. I created tape B and I created tape A. And then I created a vector for the force of gravity that was acting on tape B, and then I also created a vector for tape A that was the force of tape A, which was the electric force from tape A acting on tape B, and I equilibrated these together. Then I was able to print the magnitude. I was able to print and find values for the magnitude of the electrical force from tape A on tape B. And I was able to also find the charge on the tape and the number of electrons deficient on the tape, and then I also found that ratio. And all these values were the same as the values that I found in my actual experimental calculations. So similarities between my modeling and my actual experiment was I was modeling the same physical systems. I was also using the same physical principles and same physical equations. I made the exact same assumptions, and I had the same goals in mind. So I got the exact same results. However, differences could be the forces were not directly measured in terms of my experiment. And in terms of my actual coding, I just plugged in formulas. Also, in my coding, it was assumed behavior, whereas in my experiment, I had observed behavior. So potential error could be I had unequal distribution of charges on each tape, since I did assume that both tapes were of equal charge. Also, could have had a loss of charge due to handling. So what if we had made a tape that was oppositely charged to a U-tape? Well, instead of repelling, the U-tape and L-tape would have been attracted. The electric force would have been in the same direction as the gravitational force. And lastly, what does it mean to handle the tape as little as possible? Well, our bodies are good conductors, so this means excess electrons will flow between the tape and our bodies, which could influence the charge of the tape. If we handle the tape too much, the charge on the tape will decrease and a weaker electric force will result. Thank you.